We will now use the concepts and ideas of uniform circular motion to solve problems. But before we start, we will look at all the formulas related to an object moving in uniform circular motion. There are 3 formulas for linear speed, and there are also 3 formulas for angular speed. Formula 2, 3, 5, and 6 are related to the period and frequency of an object undergoing uniform circular motion. Then there is a formula that relates linear speed to angular speed. V equals to R omega. There are 2 formulas for centripetal acceleration. A equals to V squared over R and A equals to R omega squared. Formula number 9 can be obtained from formula number 8 by substituting equation number 7 into number 8. As a result, there are 2 formulas for centripetal force. Either F equals to mv squared over R or F equals to mr omega squared. We will use a 2-step process to solve questions on circular motion. The first step involves drawing a free body diagram for an object undergoing uniform circular motion. A free body diagram is a diagram showing the forces acting on the object. The object is represented usually by a dot. The forces acting on the body are shown by arrows pointing away from the dot. In step 2, we apply the formula F equals ma. Before we can do that, we must identify the center of the circular motion. The centripetal force is not to be shown in the free body diagram. The centripetal force is always the resultant force acting towards the center identified in part A. We apply FC equals to MAC. FC is the resultant force or centripetal force, and AC is a centripetal acceleration, and both must be directed towards the center mentioned in A. In example 1A, we have a car of mass m kg moving in a horizontal circle of radius r with a uniform speed v. We have to draw a free body diagram of the car at A. There are 3 forces acting on the car at A. One of the forces is the weight of the car, which is acting downward. Another force acting on the car is the normal reaction force, sometimes represented as R, acting vertically upward. This normal reaction force is a force that the road exerts on the car. The third force acting on the car at A is the frictional force, represented by F. The center of the circular motion is C, to the left of the car. The resultant force acting towards C is F. Therefore, write mv squared over R. Since F must be the centripetal force causing the object to undergo circular motion. Since the object moves in a horizontal circle, there is no resultant force in the vertical direction. We can therefore write down another equation where R equals to mg. The centripetal force in this question is provided by the frictional force between the road and the tires of the car. When V increases, the frictional force needed for circular motion might not be enough to provide the centripetal force. The car will then skid off the circular track.